We're going to introduce you to Delight, which is the avatar of our mind. She's modeled after an 8-year-old girl, right? So she's a little precocious. But we're going to be reading the first chapter of Little Prince with her, and we're going to be asking her all kinds of questions that she can answer based on her comprehension. So our mind, we say it's like the CPU of a computer as far as AI goes. So we need other components also to be able to give you a full AI experience. And in fact, we're going to be hooking up into the Amazon text-to-speech API, and that is going to give Delight her own voice.
So throughout the demo, you will be able to see the transparency of the operations as well as transparency of the data structure, which is the cornerstone of a mind AI.
Right. So we operate using an API, and then the UI connects to that API, and we're able to do all the types of reasoning and actually feed it ontology on the fly. And you'll see that in operation.
What is on your mind?
Right. What is on our mind? So you see as the left panel, the Little Prince, the text that you have all just read, I hope. And we're going to be going through that. All of these sentences have been given to Delight, to Mind, and we have formed canonical structures with all these sentences. In the middle panel, we have ontologies. Okay, so we say we have definition and predicate ontologies, and these are all global. So what we're saying is these are sort of general information that doesn't really change about the world. And note that it is actually, those are the actual ontologies. Those sentences are the actual ontologies. So when we give this over to the community to be able to enter their own ontologies, they don't need to learn like a markup language, some sort of programming language to give us new information. They can just tell us what it is. So you can look and see the canonical structure. These are very simple structures for the definition ontologies. Like A is a B with C, boa is a large snake, right? Or child is a young person, right? And these are the canonicals that are formed. The other types of ontologies are called predicate ontologies, and they're a little more complicated in structure, but they're still not that difficult to understand, right? Those. We say quickly that this is at the top, what we call a preparation, at the left, a rationale, at the bottom, a cause, and at the right, an effect. And the bottom two, these are where really the rubber hits the road. These are one way we can model cause and effect. And we'll see that as we go. All right, so we can start asking Delight questions, like a simple question. What is a boa?
A boa is a large snake.
Mm-hmm, very good. So let's start reading The Little Prince with her. And as the beginning of The Little Prince, you have the author as a child. She's a magnificent picture in a book. And it's about a boa eating an animal, and it's just fascinated. So let's see if Delight has some comprehension of what that actually is. Let's ask her, how does a boa eat prey?
The book says that boas swallow prey whole.
Oh, fascinating. So we're going to open that up, and we're going to show you what is happening under the hood. Right here. So this is that question, how does a boa eat prey, put into canonical form? So you see how these things sort of seem out of order, right? But they're not. Even though a canonical can function when it's not fully filled in, it's very important in what place, in what position they are placed within the canonical, because that gives it at least some of its semantic structure, of some of its meaning. So you see here, how is at the bottom, but how does a boa, and a boa we know is a snake because we've defined that, right? How does a boa, a snake, eat prey? And we have highlighted snake eat prey for a very good reason. Let's go down. So it comes to the predicate ontology, predicate canonical. So here at the right, is the effect. Snake eats prey. So we're asking, how does a snake eat prey? How does a boa eat prey? How does a snake eat prey? And that's the effect. So that if the effect has happened, if we're trying to find that, we need to know that the cause happened, because that's how cause and effect are linked. So therefore, we need to see if the snake, the boa, swallows a prey whole. And we're looking for that in the text, to have an instance of that in the text so that we know that that cause it has occurred in the text, that instance of a snake eating an animal whole. So that's our answer.
So this is very important to know that, this canonical structure means, is prey as a whole means it's a prey which deductively satisfies our data structure. So if you can see here, we have modeled the reasoning capability, which has, deduction, abduction, as well as inductions.
Okay, so this inspires our author as a child, and of course, he draws his own picture. He draws his own picture of a boa digesting an elephant. Now, so then goes to the adult. So what does the child ask the adults?
To be able to answer that, please define these words. Is adult a grown-up?
Right. So as we said before, she doesn't know everything. So that the word adult is not actually in the text. But we do have something that seems to behave in the same way that adult does. So she's giving us the inference. Is an adult and actually a grown-up? And now what we're going to do, we're going to give what we call the domain ontology, which is a just more specific sort of ontology. Right? And we're going to say an adult is a man, and a man is a grown-up. Right? This is just specific for this demo. These are called the domain ontologies, of course, and they're made into canonical forms. As it was entered, it is transformed into canonical form, and we're going to start reasoning with it right now. So we're going to ask that question once more, now that we know what an adult is.
If the first drawing frightens the grown-ups.
Right? So here's the question in canonical form. What does the child ask the adults? The child, right? The specific child, what does the child, what at the bottom, does the child ask the adults?
So here, Delight didn't understand what adult means, and we gave the definition of adult on the fly, which is forming these definitional ontological networks. So adult is a man, which is deductively satisfied, and man is a grown-up. So it doesn't really relate to directly, but it can deduce from multiple networks.
All right, so yes, see in the text, I showed my masterpiece to the grown-ups and asked them, right? I, the child, right, ask them, the grown-ups, whether, and that's the what, whether, which is the same as if, whether the drawing frightened them, and that's how we get our answer.
So this is very important to note that, the what is not in the position, but semantically it represents something it has to be understood. That's why from the question, it understands, okay, so if the drawing frightens grown up is the position of what, which satisfies semantically.
All right. Okay, so the grown-ups saying a hat, why should we be frightened by a hat? So he draws a second drawing. Now, so what do grown-ups always need?
The grown-ups always need explanations of things.
Right. The grown-up always needs explanation of things. Let's see if you can see how that works. This is a rather simple resolution. Right? What do the grown-ups, what do they need, always need, right? And then we resolve that pretty simply as that is the what, semantically, the explanation of things. We always need the explanation of things. They don't understand, they don't see by themselves. Okay, so therefore, he shows the second drawing, and then after he shows the second drawing, becomes disheartened. Let's see then what happens. Who learns how to fly?
The child learns how to pilot airplanes.
Right. Learns how to pilot airplanes. Now, we didn't ask who learns how to pilot. We asked who learns how to fly. But we know, right? We know that to fly means to pilot an airplane. Who is that person? Who learns how to pilot airplanes? Of course. No. It's the child. The child learns to fly, to pilot airplanes, to fly. He knows how to fly now.
Hello, everyone. It's Paul here. I'm going to be playing devil's advocate for a bit. I'm sorry I couldn't be there in person today, but so John, what's the difference between a decision tree that is pre-programmed and mined right now? Because right now it seems like we're searching for word patterns. How is it?
We're not searching for word patterns. We're searching for meaning, because this is how meaning is defined with us. Meaning can be seen as a change in state, which is sort of like a change in potential. And it's not, a decision tree doesn't actually seem to understand the meaning, because we actually have grounded meanings in the position they exist within a canonical. And because of that, they operate in a certain way. So it's not a binary decision tree. There's a lot of programming terms that describe it, but it is a unit of reasoning in that the types of reasoning that a human being does is replicated in that structure. So let's see. Does the pilot still have the first drawing?
The pilot keeps the first drawing.
Oh, interesting. So here is the question in canonical form. How does the pilot still have the first drawing? And we say that the drawing is an entity, and there's a reason for that. Go down. So we're invoking this predicate canonical, right? At the right-hand side, you see the effect. Person has still the drawing, right? And then we know that, oh, you know what? The person would keep the drawing to still have the drawing. So that's why the entity was important. That entity is actually the drawing. The person, of course, is the narrator, the pilot. So we can ask, why does the pilot keep the first drawing?
The drawing is important.
Yes, and this is one of the critical things right now about mind. The actual sentiment, the actual understanding that when you keep the drawing is because, keep going, right? The pilot keeps the drawing because that drawing is important. This is an ontology we've entered. This is the kind of common sense reasoning that we need to put into mind so we can understand things that come along with us. Of course, that makes perfect sense to us, but the machine knows nothing. The machine needs to know that this is how things work in the world, and that's the importance of being able to let everyone put in their 2 cents, being able to understand with us things that exist in the world and why things happen.
John, can you tell me the difference between the definitional canonicals and the actual predicate canonicals?
Right.
So what's the difference between the definition and the predicate?
Interesting enough, so they're both based on the canonical model. So what we're saying here is there are many types of interpretations that you can take of the canonical model. And the definitional ontology is one of the ways that it can be interpreted, but it's also the same canonical structure that is the predicate canonical. Now, the difference is that mostly in the definitional model, we're talking about the abductive. This has something, and that it is something, and the deductive. And that's Aristotle's definition. The definition A is a B with C. Predicates is more of the causation. Right? We call it the induction model. It's a little different from what you think of as induction because the induction has already been made. We're not making new inductive models. That is the inductive models that we're following. And that is actually causation, it's action. And that's more reliant on the bottom link to be able to perform. So that's the main difference between the definition and predicate canonicals.